Okay, everybody, this is section 10.7. If you have a book, we are on page 576. It's the last section in the chapter. And the title of it is Circles in the Coordinate Plane, which is the reason why I have moved my magnetic board over to here so that we can get in the coordinate plane with these things that we're going to be doing. But before we get started, I want to know if I say these words, if it means anything to anybody. You remember doing transformations in Algebra 1. So let me show you an example and see if this looks at all familiar to you. If we talk about a parent function, which is x squared, if I do this to it, do you remember that means that moves this parabola to the right too, because it's inside the parenthesis? Do you recall that idea? And then if I, in addition to that, add a 4, it takes this parabola and moves it to the right 2 and up 4, because we take this as is, but we change the sign on that when it's inside the function. Remember that?
Yes.
Okay. If you recall that pretty well, then I just need that in the forefront of your memory in order to develop the next part. So, okay, so here is a circle that's centered at the origin, has a radius of 5. And we're going to try to develop an equation for it. There's some things that I would like you to notice. If I were to draw a triangle that goes out 4 and up 3, that would be a point on this because 4 squared plus 3 squared is 5 squared, and the radius of this circle is 5 no matter where you draw it. So this is a point on the circle, right? The point 4, 3 is on the circle. But so is the point 3, 4. I mean, I'm just doing things that have whole numbers to them. I just want to show you something. These are both right triangles. This one stands up a little taller, but this is 3, which is when you square it is 9. This is 4, which when you square it is 16. 9 and 16 is 25. Square root is 5. So I know that the point 4, 3 and the point 3, 4 are on this. It's also true if I do it down here. If I go back 4 and down 3, I end up with a point on the circle because it's 3, 4, 5, right triangle. If I go back 3 and down 4, I end up on the triangle. On the circle. Well, if I did that in every quadrant, those are points that would be on it, but that's only 8 points, and the circle is made up of billions of points, right? So if I didn't do something quite so nice and pretty as a 3, 4, if instead I wanted to look at this point right here, that would cause me to move out here till I was hovering right above that 4.8 or 9 or so, and then come right straight down to there to about 1.7, if I've got the circle drawn right. That's also a point on the circle. And I'm here to tell you that if you use this, which is about negative 4.9, and remember, I'm freehanding this, and at about negative 2.7, this one right here. Let's see how close to 25 we get with that, just for the fun. So if instead of having a nice 3, 4, because they're nice whole numbers, if instead I got these crazy things, let's see how close to 25 we can get. So I would take parentheses negative 4.9, close it, square it, that's a leg. Add it to parentheses negative 2.7, close it, squared. I get 31.3. That's still quite a ways up, but understand I freehanded this, and that may not be quite 2.7. It looks to me like maybe more like 2.6 or 2.5. So I'm going to change that to C. It didn't get me much closer, so my argument isn't making very good sense. Pretend with me that I don't know what this is. Maybe it's not negative 4.9. Maybe it's negative 4.8. But all I'm saying is that if that's a point on the circle where this is 5, and the circle has been drawn perfectly, and I can find these points perfectly, that's guaranteed that this length squared plus this, probably about right there, and plus that length squared has got to be 5. And so there's all kinds of triangles. If I wanted to do this one right here, I would go out to what was underneath that, go up, and then I would have another one. Whatever length that is, it's probably irrational. And whatever length this is, if I square them and add them and square root them, I'll always get 5. That's true of any point on the circle. Does that make sense? I don't care what point I choose. I can draw a triangle such that this leg squared plus this leg squared will give me 5. And all such x, y combinations that do that will be points on this circle. And so the equation of this circle is whatever x is squared plus whatever y is squared will equal 25. And all possible combinations of x, y's that make this true are on this circle, all billion of them or more. What? Speak. Jamari?
Oh, I have a question.
What?
I did not have a question.
Oh, well, look like you had your hand raised. Okay. Does everything I've said so far make any sense? This is the equation of a circle right here. So based on what we talked about with transformations a second or two ago, if I don't want the circle to have its center at the origin, does this make sense? That if I still have a circle that's a radius 5 like this, that I could move it off the center by doing this? Let's say I wanted to, not h, but let's make it an actual number. If I wanted to go x minus 3 squared and then plus y plus 4 squared equals 25. Does it make sense to you based on what you've learned about transformations that it's going to take this circle and we're going to grab the center and we're going to go right 3 and down 4? Because they're inside. Both of them are inside. And so if I were to take this center right here and go to the right 3 and down 4, put it center here instead and make a radius of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The only reason I'm counting is because I want something to shoot for. I would move that circle to right there instead, because the center moved. It doesn't have to be on the circle. That was sheer coincidence that I did that. I used 3 and 4, which we've been using all day, but then move the center right 3 and down 4 and put the center at, the center of this would be the point 3, negative 4. That's what this does to it. And the radius, and by the way, I'll show you this in just a minute. The radius would have to be 5 because this is 25. Whatever this is, you square root it because it's squared up here. This was x squared plus y squared, if I really go to the first version of it, is equal to 5 squared. I just put the 25 there because I squared it in my head. But this thing right here is the radius, which was 5 squared to fit the Pythagorean theorem. Have I lost anybody? Okay, so when you see something like this, a circle with that kind of an equation, you can tell where the center is by changing this sign and this sign because it's subtract of each thing. Give you your center, and whatever's on the end over here, you square root it to give you the radius of the circle. And if you know where it is and how big it is, it's completely defined on that grid. Where is it? How big is it? That's all you got to know. And the whole thing is completely defined. And they're given to you right here if you know how to read it. So in a general way, we say this: x minus h squared plus y minus k squared equals r squared, numbers except for the 2's up there. This is Pythagorean theorem. If you have a circle of this form, we know that the center is at the opposite of this, which is h, and the opposite of this, which is k. And the radius, of course, is the square root of r squared. Whatever that is, you square root it, and then it'll give you the radius of it. And that's all you need. Does that make any sense? Okay, so let's do one more like this. If I have a circle like this, x plus 4 squared plus y squared equals 10. Can you tell me what the center is? Negative 4, 0. Yep, because there's nothing being added or subtracted here. And the radius is? It's better to just write it like this. The radius is the square root of 10, which is ever so slightly more than 3 because the square root of 9 would be 3, right? Okay, so if you were given this and it said graph it, you would first find those two things, and then you would plot the center right there, and then you would count out a little bit more than 3 in all 4 directions. 1, 2, 3, little smidgen more. 1, 2, 3, and a bit. 1, 2, 3, and I'm really saying a bit. If you actually make it 3, I'll probably still give you credit. 1, 2, 3, and a little smidgen. That gives you, if you count up along the like on the crosshairs of this thing, it gives you something to shoot for when you have to freehand your circle. Because I'm not going to give everybody a compass for this. I'm just not. Just do your best. But that is the graph of this circle, because this, if you know how to read it, tells you where to put the center and how far out to count. You follow? Now, let's go in reverse. What if I told you that I had a center, the center of a circle that I want to write and graph? The center of the circle is negative 4, 1, and the radius is 6. Can you write the equation? What would it be?
X.
Parenthesis first, right?
Oh, yeah.
Yeah, parenthesis
X plus 6.
plus. It is plus, but plus what?
4.
4.
Oh,
It's the x coordinate of the center. That's your h. Squared. Remember to square it.
that's great.
Plus
Plus
X.
Y.
Plus
x. No, sorry, not x.
Y.
What is it?
Plus
Y. What is it?
plus 1.
Plus 1?
Minus.
Minus 1 squared equals 36. That's correct. Does that make sense to you? You were a little hesitant on that, so let's do another one. What if I told you that the center was 0, -5, and the radius is, the radius is 2.7. What's the equation of this circle?
X.
X?
Parentheses X.
No.
Plus.
Here's why, because that is 0 this time. It's not x minus 0 is just x, so it's just x squared. You see?
Yeah.
Then plus, because that's the Pythagorean theorem, plus parenthesis
Y plus plus
y plus 5,
equals
not yet, squared equals
7.9.
approximately 7.9. Yeah? Now, it isn't exactly 7.9. Well, is it?
It's 7.29 exactly.
Oh, 7.29 exactly. My mistake. I'll stop there. I was going to say something, but I won't now. Okay, so 7.29 is that thing squared, and that's the equation of that circle. To graph it, you would plot the center and count out 2 and most of the next square. Because the graph paper that I give you, that I let you use, the squares are super, super tiny. So trying to get exactly 0.7, I'm not going to count that against you. Somewhere between 2 and 3, you would count out and then connect the circle. Does that make sense? Okay. With all of that in mind, that's about probably 80% of today's exercise. But there's a little bit more that's going to require you to think a little bit. Let me see if I can find a problem with that example. Okay, let's take a look at example 2. Let's see if we can understand what they're saying and how we can figure out how to write the equation. In order to write the equation of a circle, in order to write it, you have to know the center and the radius. And if they don't give those things to you, you got to use the math skills that you have so far to come up with them based on the information that they gave you. So look at example 2. It says the point -5, 6 is on the circle. -5, 6. That point is on the rounded part of the circle somewhere. It's a point on the circle, okay? And it says the center is -1, 3. Okay, so what this says is that this is a point which is actually on the rounded part of the circle. This is the center, so we would start there and we would stay the same distance from the center all the way around to actually get it graphed. We could do it with a compass. We could graph it. That's not what we're supposed to do. We are supposed to find the equation of it. So I can write this much right now. If I know that the center is at -1, 3 squared plus y minus 3 squared equals. I can write that much of it because I know the center. But this number right back here is the radius, and the radius is the distance from here to one of the points on the circle, right? And I don't know what that length is because it's slanty. But I can find it if, again, I'm clever with triangles. This just happened to turn out really, really nice. If I make a triangle out of that and I want to find that distance, this is 4, this is 3, and hopefully by now you realize the Pythagorean triple that has legs of 4 and 3 makes this 5. Because 9 plus 16 is 25. You following me?
Yes.
So I now know the radius length. It's the distance from the center to that point they gave me, and I had to use a triangle to find it. Since it's 5, this is 25. You all agree?
Yeah. Yes.
Okay, now, let me try another couple with you, a couple of these things so you don't have to hit this cold. I'm going to make my own up now because I've only got one like this, and it turned out so pretty and nice, and then the ones they make you do don't, so I'm going to give you a little bit tougher one. If I tell you that a point on the circle is 2, 4, and the center is located at 1, -1, That's the center. And so because of that, I can begin to write, remember what I told you it was, it's 1, -1, and I can write the left half easily. That's going to be x minus 1 squared plus y plus 1 squared equals, and now I got to find this. So I got to find this length right here. And so since I've already put it on the grid, or that's what I would do, I make a right triangle out of it. There's a little tiny leg down here and a really tall one there. This is 1. This is 1, 2, 3, 4, 5. This is 5. 5 squared is 25 plus 1 squared is 26. This right here is the square root of 26. That's the length of that segment, right? But here's what's cool. In the equation, whatever the length of that is, you square it. And the square root of 26 squared is 26. The radius was the square root of 26. And whatever that radius is, that's the distance between the center and a point, whatever that radius is, I square it. Remember the last radius was 5? We squared it, got 25. If you square root 26, that's what you're supposed to do, you get 26. Yeah? So this is that equation. Does that make sense?
Yeah.
Okay. Now let's try another one. It's got different information about it. What if I tell you that the center of a circle is located at 4, 2, and the circle itself is tangent to the y-axis? That would give me x minus 4. I can write this half over here. They didn't give me another point. They said that the circle, when I draw it around that center, is going to be tangent to the y-axis. If that's the case, then the thing's going to come around, and right here at this point, it's going to snug right up against there like that. I know it's crappy, but that's what's going to happen, which means that's the radius. Because it's tangent to the y-axis, and that's an easy thing to count. You don't even have to figure anything. You just got to understand what's going on. That's the radius, which is 4, so this is 16. You follow that?
Yes.
Now let's say I said instead, same center, but this time is tangent to the y-axis. Then it means it's going to come snugging right across like that, and the radius is now 2. In which case this would be 4. Now if I said the center is at 4, 2 again, same thing, and is the circle is tangent to the line x equals -3. Do you know what x equals -3 looks like from your experience in algebra? Is it horizontal or vertical? Vertical. This is x equals -3. If it's going to be tangent to that as it comes around, then the radius will be this, which is 7. So this would be 49. You okay with that?
Yeah.
And again, just to make sure I've covered all the bases here, same center, but is now tangent to the line y equals 8. Y equals 8. Y equals is a horizontal line. And so you would count up to there. 1, 2, 3, 4, 5, 6, and put 36 there. See it? It's not that hard. You just got to understand what the words mean and how it's going to affect the way you write the equation. It's usually this that they make you go find, either with Pythagorean theorem or by simply counting to the tangent line. That's it. And the assignment is super short. For Friday, it's super short. Yes. Okay, here it comes. You ready? Section 10.7. The assignment is 3 through 11, and it is not odd. So it's 3 through 11, all of them, and 13 and 14. 3 through 11, and 13 and 14. That's 11 problems. You got lots of time. Should not kill you to get that done. And then you won't have to take any homework for this class anyway.